Of worksheet number 8 on our radical review. Looking here at this learning target, we're going to multiply radicals. Outside with outside, inside with inside. So the first thing I'm going to do is 4 times 6, and I'm going to get 24. And then root 2 times root 10, I'm going to have you do root 20. Okay? Now, towering root 20, you may have to take some time here to tower these, but we've seen that one a few times. That's actually 24. Look at the 24 just carries down. It's 24 times root 20. So we're going to multiply by 2 root 5. Now, I've simplified root 20 a lot of times here in my career. I know that it comes out to 2 root 5. If you need to tower, don't feel bad. So now we take the outside with the outside, and that's just going to be 48 times the square root of 5, final answer. Okay, that's not the only way to do this problem, but that's the way we've been kind of consistent with it in class. So when you look at number 12, that's the square root of 140, all under the same radical sign. So if I'm going to tower 140, I'm going to divide by 2 and get my 70. I'm going to divide by 2 and get 35. I'm going to divide by 2, doesn't work. 3 doesn't work. 5 and get 7. Circle cross. And now I have a 2 that comes out. The untouched goes back inside, and there's 5 and a 7 multiply to give me 35. Final answer. Outside with outside, so I have negative 12. 3 times negative 4 is negative 12. Root 2 times root 8 is actually multiplied by the root of 16. And then don't forget, you do not need to tower that one. The square root of 16 is just 4. So the final answer to that is negative 12 times 4, which is negative 48. Same thing here. Just think you have a 1 out front. Outside with outside is just a 3. Inside with inside, well, that would be root 25. But we've been recognizing that that's really just the square root of 5. Square root of 25 is just 5. So you have 3 times 5, which would be 15 for this problem. All right, now we're going to have to distribute through for these problems. Outside with outside, first distribution is 8 root 3 times 2 root 5. So that's going to give me 8 times 2, which is 16, times the square root of 3 times the square root of 5, which is the square root of 15, inside with inside. And then when we carry through here, minus 8 times, and I could say the square root of 9, because root 3 times root 3 is root 9. But we've noticed that that's just the number 3. So that does create an outside number when you take 2 inside numbers, but 3 times 3 is 9, square root of 9 is 3. So this is going to be 16 times the square root of 15. You should try to simplify 15, but we can't. And then minus 8 times 3 is 24. You can't go any further than that. They are not like radicals at that point. Okay, on this one we're going to FOIL. So here we go. 5 times 9 is a 45. Outside is plus 5 root 6. Nothing can really go together there. Inside, same deal, plus 9 times the square root of 2. And then the last is root 2 times root 6. That's a positive root 12. So actually, this one's almost done. You can be like, there's nothing to do. But looking right here, I can actually simplify the square root of 12. So this is going to be 45 plus 5 root 6 plus 9 root 2. And then plus, that's really, when you simplify it, 2 times the square root of 3. There are no like radicals here. There's nothing else we can do to put together. So that long answer is our ugly answer to this problem. All right, moving on to learning target 11D. We've been getting better. We still need some work. But looking right here, what I have is both numbers under a radical. Yes, you could multiply by root 50 over root 50. A lot easier to simplify to 1/5 here. Now, please understand that's really square root of 1 over square root of 5, which we need to multiply by root 5 over root 5. Remember, we do that because we rationalize the denominator here. We're trying to get rid of radicals in the denominator. Like we've been saying, inside with inside, root 5 on top. And then on the bottom here, root 5 times root 5, root 25, which we know is just 5. That is the final answer, folks. You cannot simplify inside with outside, so that would be it for that problem. All right, look at this one. I would highly suggest, again, simplify first. 6 over 3 is really 2 over 1. Square root of 60, square root of 15. Well, 15 actually goes into 15 one time, and it goes into 64 times. So I'm going to clean this up. Be very careful. That says 2 root 4, don't lose the root, over 1 root 1. Well, this is working out really nice because this is really 2 times, well, square root of 4 is really 2. Recognize those perfect squares whenever you can. And then 1 times root 1 is really just 1. So this is actually coming out to the number 4. You could get that by multiplying by root 15 over root 15. You could definitely do that. Your numbers would be larger. You'd be simplifying radicals. All right, looking at this one. Multiply here by what we call the conjugate. Not root 5 over root 5. We've said why in class that doesn't work. So we're going to multiply the top by 9 plus root 5. And then the bottom here by the same thing. Now on the top, we had good practice before of distribution. So that's going to be root 3 times 9, or 9 times the square root of 3. And then we're going to have plus root 3 times root 5, both inside numbers, root 15. All over, looks like we're going to have to FOIL the bottom. First, gives me 9 times 9, which is 81. Outside, inside, completely cancel off. They'd be 9 root 5 and negative 9 root 5. They're gone. And then we have minus root 5 times root 5, which is just 5. So what we're going to get here is the bottom number being 76. Now looking here, you definitely want to simplify all outside numbers if you can, but we can't. There's nowhere to go on that problem. All right, let's try green here. Same deal, conjugate, but not the conjugate of the top. We want to do the conjugate of the denominator, because that's where we're trying to get rid of the radical. Okay, so you can see here I just made a mistake, and I'm going to have to fix it. This right here is supposed to be a minus sign. So let me fix that. The conjugate is 5 minus. Let's see here. There hold on. Okay, I'm back. We have 5 minus the square root of 2. So when we do the top, it gets a little ugly because we have to FOIL that as well. 2 times 5, 10. If this is too fast, rewind it. Watch it again. First, outside is going to be minus 2 times the square root of 2. Inside is going to be plus 5 times the square root of 3. And then the last would be minus the square root of 3 times 2, which is root 6. They do stay inside there because they're not the same number. All right, and then the bottom first would be 25. Minus the last, because the outside inside cancel again, and you're going to get just 2, because root 2 times root 2 is 2. So if you look up at the top there, 10, 2 root 2, 5 root 3, root 6, there's no radicals I can simplify, and there's no like radicals. So the top is actually completely simplified. So if you look at the bottom, and if we just make this 23, we have the final answer to that problem right there. There's nowhere else I can go with that. All right, here we go. The last learning target of the chapter, solving radical equations. So what we're going to do is step 1 on your notes says, get the radical alone. Well, we have to add 10 to both sides first. Oops, sorry, I don't know why it's doing that. Okay, so add 10 to both sides. So this is going to be 5 times the square root of x plus 1 equal to 10. And then this is 5 times. The radical's not alone yet, so I want to divide by 5. Cancels here, and it's going to create a 2 on the right side. So we're going to have root x plus 1 equals 2. All right, then the next step after we get the radical alone would be to square both sides. Running out of room, so I'm going to go up here with it. That really becomes just x plus 1 on the left, and on the right side, 2 squared is 4. So what we get here for an answer is x equals 3. Now taking this answer and plugging it in, 3 plus 1, that's actually 4. The square root of 4 is 2. 2 times 5 is 10. 10 minus 10 is 0. It does check out. Life is good. If that was a little fast for you, rewind that part and watch that again. Hey, I got a radical equal to a radical. You got to love these because it's a radical. Oh, sorry. We're going to square both sides. So you're actually just going to get x plus 6 on the left, and on the right we're going to get 2x minus 24. Now if we subtract x from both sides, this is now just algebra. I'm going to subtract x from both sides. I'm going to get an x on the right. These will cancel. And in the same step, I'm going to add 24. Get these to cancel. And then when I add 24 to that side, I get my answer of 30. Again, I'm going to save the effort here, but if you plug it back in, that one is going to work out. Down here, the first thing we would want to do is subtract 6 from both sides. So we're going to have 3 times the square root of 2x. That equals negative 6. Then I'm going to divide both sides by 3. So what I have here is the square root of 2x equals negative 2. And it is at this point, since I have a lot of experience with these, I realize the square root cannot equal a negative number. So it's not going to happen. We're going to get no solution to this problem. Now, in green here, I will show you what happens if we solve. Okay, but if you have a square root equal to a negative, no solution. Not a cube root, that's a different story, but a square root is going to create no solution. But watch this. Let's say we would have squared both sides. That would have created a 2x on the left. You with me? Squaring the left would be 2x, good. And then on the right, that would be negative 2 squared, which would actually be 4. But then dividing both sides by 2, we would have gotten an answer of 2. What happens when we check it? 2 times 2 is 4. So it really says 3 times the square root of 4 when I plug that in. Well, that's 2. So that's 3 times 2, or 6 is coming out. Plus 6 equals 0. It's not working out. So if that doesn't work out, you should give me a no solution for your answer there. Careful, they won't all come out to no solution, but one of them might, and you got to be ready for that one. All right, looking here, same thing. We want to subtract 6 from both sides. This is going to create a positive number, and it's a cube root this time, so there's really nothing to worry about. Cube root of 2x plus 2 is equal to 2. Now, we square or cube both sides. So this scenario, we're going to cube both sides. So now I have myself the 2x plus 2 equals 2 times 2 times 2, which is commonly known as 8. And then when I subtract 2 from both sides, 2x is equal to 6. And I'm going to get my x value of 3. Plug it back in. It works. Guys, I hope that these videos have helped you. I went a little quick on this one just to make sure that I could get it online for you tonight. But I really hope that your frown is turning upside down and you are really learning how to radical maneuver through these problems. Thank you so much. Make sure you're seeking out more help if you still need it.